Yeah, the multi is just or the Duro is just a multi, as I understand, with case and carrier board with all the connectors.
Yeah, I guess I've seen it in there. If you do the software settings, it talks about turning on the INS or the IMU that's on there, and I've just never played with it. So.
Yep.
So maybe you can turn it on for the multi. So.
Yep.
We'll have to see how that goes.
I was telling Matt, I've got to go. I'm just arriving in Iowa, and my daughter needs to go to the restroom, so I'm going to cut out.
Okay.
Have a good trip. Good luck tomorrow. Evening, Sohin, what's happening?
Oh, hey. Just back from work. Nothing exciting. I did get a chance to meet some people from the state transportation department today. It was interesting to see their perspective on autonomous vehicles and stuff, but that's the only thing that's happening on my side. I guess we're gonna work. Some of our teams have started working on the smaller version of the robot, so I was consulting them to, get it right this time.
The one that you used a couple years ago?
Yes, the one that we used in 2017, the smaller version. It's 30 inches in diameter. I'm sorry, not diameter, but in width. So it sits directly between two rows of corn. But it's pretty interesting. It's like a smaller version, kind of like what others are doing these days. And we already had the chassis, so we thought we would revive it with all the new funding that we've got. Trying to put more sensors on it this time, hopefully encoders and other things, but less work, more output, that's the hope. But that's all that's up on this side.
That's good, Sohin. You guys are getting a head start on the competition.
Mm-hmm. I'm planning to graduate soon, so I'm trying to give as much as I can, trying to train them before, I set off. But that's the hope. Trying to teach more people ROS, that's also pretty interesting. I've had a few people who are really interested in learning, so I'm trying to, just give them a head start in learning most of it. So, I think it will help them too in the future.
Yeah. That's awesome. You're the mentor. You're the team mentor now. You get to pass the torch.
Yep, I think so.
Jeremy, how was H-ROS? Are you back now? Is you on the right time zone?
Yeah.
You get to meet the King of Spain.
Yeah, that was interesting. I kind of got trapped in with him in the exhibit hall, so he did a surprise attack, I guess. But it was good. I caught a little bit of a sniffle on the way there, and I got to hang out with Sohin for about 3 hours, I guess, or so. So we had some fun, and it was pretty cool.
Yeah, I just saw Fetch announced a partnership with Intelligrated. It was pretty cool. Yeah.
Yeah. That's why I said hi to him when we were walking out.
Yeah, I figured that. I thought for a chance, to know it firsthand. It was fun, I guess.
Yeah. Yep. So yeah, it's an interesting thing. So, but yeah, we've got a partnership with them, and I guess we'll see how that pans out. So, did you see any? I mean, I only came in the last half of last day. Did you already report on the rest of ROSCON? And I guess the talks are up now, so everybody can watch them.
Yeah, I did. I did talk about it last time. I just mentioned a few of the interesting presentations that I liked, and just my views on. Just my recommendations on something like must-watch things from ROSCON, I guess.
What were your must-watch things?
Well, let me pull that up. I can share the presentation I made for that, but it's also on the on our last meeting.
Oh yeah, I can just watch that. Okay.
Yeah,
Fair enough.
Yeah.
I was going to say, I mean, for the handful of presentations I saw at the end of the day, the one I found most fascinating was the record replay.
The debugging.
Yeah, you and I talked a little bit about that.
Mm-hmm.
So Matt, this is like, I don't know if you remember, but we were using, what was it called? So Green Hills Integrity had like a method of recording debug stream into a separate device, and Mozilla has a record replay functionality that this guy has integrated with ROS. So it's basically like using a breakpoint debugger, GDB, and being able to set breakpoints, and then instead of continuing forward, you can actually continue back. So it keeps track of last instructions, and so you can move the instruction pointer back in time, which is a real fascinating concept for debugging.
So when you're
Yeah, got it. I couldn't have explained it like this. Zoom has this new feature when you start talking and your mic is muted, it tells you that your mic is muted. Yeah, I didn't. Yeah, I didn't do a better job at explaining this one, but you did a far better job. So
I really like that. That's going to be a good thing.
That'd be a neat package to demo, kind of showing how you use the debugger and what areas it would come in handy.
Yeah, he did a fairly good demo. The presenter did a fairly good demo of it during the talk. But yeah, I think if you hadn't heard of or used something like that before, it might not mean so much to you. I mean, basically, he's capturing in a recording non-deterministic events and recording those, and then when it hits a deterministic part, in other words, instructions, or like A equals B plus C, after after a callback, it would do those in sequence, and then you could kind of step back and as well. So I thought that was really cool. There's also a lot of ag robotics at HRIM. I don't know. I didn't get much into that while I was there, unfortunately, because I was busy doing work-related, stuff. So, but I think it might be. I don't know if they're going to share any of the videos from that, but I would go back and I guess my advice would be, if you go back to the HRIM 2018 website, especially look at the exhibit hall, and there's kind of like a wedge-shaped piece of, like, it's hard to explain the exhibit hall, but there's kind of a central area, and then there's a smaller area to the right side, and then there's a kind of moderately sized area to the left side. Well, this moderately sized area had all the ag robotics, and they had some pretty interesting systems, and I didn't get an opportunity to stop and talk to them, but I think if you went on the HRIM website and looked at the exhibitor list and the layout, you could probably find their websites, and it seemed like there was some kind of harvesting bot for, I want to say, like some kind of soft fruit like strawberries or something like that, and pretty interesting stuff.
Excellent. Were there any papers or anything you saw at H-ROS that was most fascinating? Besides Boston Dynamics and the King's Fade.
I didn't get to go to the Boston Dynamics talk. They had the worst venue ever, and it was so hard to get around that by the time I got down there, they had shut and locked the door. Well, not locked, but they had posted like security at every entry into the auditorium. So I didn't get in there, and I instead went upstairs to the exhibit hall, and that's when I guess he left that early, and that's when I got locked in with him, because he came upstairs to look at the exhibits, and I was in there already, and then they shut the entrances to the exhibit hall, so that was kind of weird. But yeah, it was kind of a bad thing. As far as papers, I know they had a lot of talk about UAVs, and in the, I think in the ag space, I think they had several talks, not talks, but the format is for the paper presentations. The format is they have a initial discussion, initial presentation. So each paper, say there's 8 papers in a session, gets 3 minutes to kind of give an overview to the entire audience. After each of those 8 people are done, then they have these special, what they call interactive sessions, where the presenters go to individual monitors around the room, and you have the opportunity to go up and ask questions and kind of learn more about what is going on. But like I said, I didn't really hit anything agriculture related. So that, having said that, I think the most interesting thing to me was the concept of grasping. If you're interested in manipulation of, you know, not just mobile robotics, but arms and picking objects and stuff. In grasping, they were talking about a lot about using the environment to grasp objects instead of just a lot of detection. A lot of grasp planning and planning right now is all about detecting an object, figuring out which surface you're going to put a suction cup on or grippers on, and, you know, trying to go straight for it. A lot of these new other techniques that we're talking about, like the way people pick up things, like putting your finger on, like if you picked up your pen off of paper, you might put your finger down on either side of it and hit the paper and then pinch inward. So they're talking about how you're using the environment to kind of, I guess, constrain the problem. And that was pretty interesting. I never really thought about that method before.
Awesome. Are they using things like reinforced learning to do grasping, or is it all just programmed?
If there was any subject that overwhelmed any other subject at H-ROS, it was AI. There was no less than probably 2 tracks at any given time specifically addressing deep learning or machine learning or reinforcement learning or demonstration, learning from demonstration. All these techniques were, you know, like everybody was talking about it. I mean, you couldn't walk 10 feet and not hear about something like that. But they were all pretty much the same deep learning techniques discussed, like mask RCNNs and CNNs. There's a couple, YOLO is one that we were using at work. There was a couple other ones I hadn't heard before, but I think it was a reinforcement learning example. So those are kind of interesting. One was, I think you could probably find a video online, but it was called Learning to Pour. And they basically trained a robot arm to pour a glass of water with using, I guess it would have been a reinforcement learning technique, because they have like a cost function to optimize. So it was kind of neat.
It's fascinating. It'd be cool to see once these things start to get out of research and into ROS packages. I think that's going to be great to see.
Yeah. Yeah, I mean, Ricardo has some interesting, I think he has one class on using OpenAI. So that might be something to take if you're interested as a starting point.
I missed he had a class on reinforcement learning. I missed that today, but you can go back and watch that one. But yeah, the OpenAI Gym and Gazebo simulation.
Yeah, who was he talking to? I think I remember seeing that. Oh no, I was thinking about H-ROS. Did you guys know about H-ROS?
Mm-hmm.
Yeah. Remember seeing that, Sohin? We were talking to him for a while.
Yeah, it was pretty cool. I don't know if you followed up with them or anything. I mean, it's not. I was just fascinated by the stuff they had, and then robotics gave me this nice packet. I don't know if I have it here. I put it somewhere else, but they gave me some of the controllers that are ROS2 enabled. So and I think there was also a talk about ROS2 in microcontrollers. I might or might not have included that in my list of things to watch, but yeah, people are moving towards ROS-based controllers. And I think from that trend, this time for the new AgBot, we got the Polulu motor controllers that come with a ROS package, so you can interface and with the Polulu roboclock. And the best part is that it automatically hears, or it automatically starts listening to CMD well, which is pretty cool, because all you have to do is like hook it up and then give a UDEV rule, and then it starts listening, and you fire up the node and it starts listening to a CMD velocity. So now on your side, all you have to do is hit the PID, like do the PID control, which comes in built with their software. So hook up the motors and it will find the, KP, KD values by itself. I mean, I hope I'm being clear enough, but it was pretty cool. And I think that's the way forward.
The only thing I didn't get out of them was like which motors, how universal was it? Because they kind of made me believe that it was universal, but I couldn't get I can't believe that it's entirely universal control, because there's a lot of different types of motor interfaces and servo interfaces. So I was hoping to get some kind of.
I agree with you. I went back to their website and they have listed a bunch of interfaces like I2C and SPI and others on there. So I'm assuming, so if you don't use one of those, I think something called Hans motors, if you don't use one of those, then you can possibly hook up another one using those interfaces that they mentioned to you. It would be interesting to see how that works out. But yeah, the only thing is, I like the modularity, but I don't see how it relates or how it connects to other arms, unless you use their controller on each of the modules of a different arm. So it brings back to the point where, like, if you use someone else's arm, if you use another arm, and if you wanna, use a universal gripper, then you'll have. I'm presuming that you will have to put a chip, the SOM on each of the joints, I guess.
Yeah.
Or how would that?
Yeah, I mean, it's kind of like every motor that you needed would have to have the H-ROS system on the module.
Exactly. So, I mean, then why would you pay so much money to buy another robot? It kind of defeats the purpose of buying an ABB robot and then trying to put an arm, like a gripper on it, because you'll have to get into their system and connect their motors with the SOM from H-ROS.
Yeah.
I don't
know. It still seemed like something interesting. I know they've been working on it for a few years now. So, but
I like that the processor runs real time. That little processor for H-ROS, they have real time operating system, and then they have hardened code on there. So maybe for a safety system, I mean, you might be able to use that module for other things.
Yeah, I think I asked them, I mean, Sohin, you can correct me if I'm wrong, but I'm pretty sure I asked them about the safety standards that they adhere to, and I think they're working on that, but they don't really have, they're not really adhering yet to any safety, functional safety standards that Jonathan would have talked about a couple ago.
I think the power of the H-ROS is not so much into the hardware at this point, because I think that's their business model. The way I see the HRIM, the component, the modeling, what they're bringing out, and trying to build the kind of protocol across the board with how you actually design the whole, the component model system based on, so be it if everyone has a sensor, or you have the actuators, you got the communications, UI, all those things that you need. If you see the standard that they're trying to build around the HRIM, that's what they call it. I was looking at it, and there is a systematic way of doing things. They're developing the messages, they're developing the communications, making it more standard, I guess, so that if more and more people would embrace that, it means that most of the hardware side of the thing would become in the future, like kind of plug and play with a little bit of tweaking here and there. I think that's where it has a lot of power that I can see. I was looking at at this point, I encourage all of you guys to just take a look at the HRIM, the modeling, what they're working on. Basically, I think they've just started working on it. They have the I think the kind of a blueprint. The infrastructure is ready. I think they have the grant from the ROS Industrial, the Horizon 2020 thing, and then they're going to be working on it for another probably 9 months to a year or something. It will be very interesting that what comes out of that, the project that they've already started building. I think I'm pretty much impressed with their model and the concept of the HRIM. Not so much the product, obviously. The product is probably on their business side of things, and probably they're ahead in the game at this point. But I think on the ROS perspective, ROS2 perspective, what they're trying to bring it out, I think it's just coming across the hardware side of the things. It'll be good to see like after a year that how it kind of pans out, and if if the ROS side of the world or industrial side of the world started adopting those things slowly, gradually, or if it just takes any new direction, who knows? But I think at this point, I'm getting impressed with what they have divided their whole modeling into the subsystem or subcomponents part of it, and making it more easier. That's what probably we should keep an eye on too. I think there's a lot of potential into those areas. And when you separate it out, and there are like certain hardware, like going forward, you would see probably from the vendor that would actually give this set of communications, like standard message type that HRIM laid out, probably by default. And I think that would push, a little more plug and play behavior. Not sure, I'm just guessing at this point, but I think that looks like more of the future too. That's kind of my 2 cents.
That sounds pretty good. Yeah, I wasn't familiar with that, but I was just looking it up.
Yeah, if you and those the message type and the structure of the whole thing, how they're actually trying to bring it out. Like, look, for example, if you just look at the sensor, and then they're like it points out to so many sensors. Like, for example, you got the 2D cameras, 3D cameras, or you have any other sensors, and then you go underneath that. You will have the message types laid out. You have the component that what should be there, what's just minimum required kind of a deal. So I'm seeing there that they're driving the whole protocol, like the standard for the industrial side of it. And I think that it has a lot of potential. That's like a new way where if any hardware vendor in the future is wanted to design something, and if it has to support the ROS2, let's say, for example, and if it's in this format, I think it would increase the, like I said, the adaptability from one, hardware vendor to the other, to the other, to the other. In that case, you will have mix and match hardware, and that should talk to each other with simple tweaks, like going forward, like within 2 to 5 years, maybe. And then, like after 5 years, you would have something plug and play. I was looking at that one of the movies, the Chappie or something. It was just, I don't know, just the on the robots, and the guy's just losing one of the hands, so just it was just the robo, so it's just someone else is, oh, here I have one in the junk, and just put it on, and then just actually kind of a plug and play. So it just, as soon as they put that hardware on, just recognize the whole thing and programs it automatically. So I think probably next 10 years, and you would see that behavior in robots. It's just not that far away. I'm hoping. I'm optimistic.
Self-assembly robots in 10 years.
The way and it just because of 2 reasons, the hardware is getting so cheap. And with the machine learning and the artificial intelligence is marrying up with the robotics knowledge, the possibilities are endless at this point. We just talked about OpenAI, which is part of the reinforcement learning. There are so many other projects, depending on the deep learning, there is going on. I believe that the grasping thing, the arm, and the manipulation of the arms, and like the move it, will actually move forward with a lot of machine learning, and the deep learning libraries is kind of sort of included. The grasping at this point is just one of the toughest thing, the soft grip, the hard grip, the suction cup, the suction grips, whatever it is, just right now it's just really hard. You need the very sophisticated cameras, in order to just grasp with certain, even small things. I think going forward, that would not be the case. I think at that point, you would just the AI would marry up with the camera, and then just makes that thing so easier that the arm should work in a very dynamic fashion. Like you don't have to worry about it where the things are. Not just like the cell manufacturing. It just will be really dynamic. you know, like where the atmosphere is changing, you know, the objects changing, the things changing, but your robot just working as efficiently as it could without any reprogramming. I firmly believe that is coming in the next 5 years. But yeah, HRIM is just something that I think I'm keeping an eye on. I liked it. Just really nice, you know. There's a lot of growth potential there, and that's what I'm waiting on. Like they have this project for like 10 months to a year or something. It'll be interesting to see that, you know, what's the outcome of the project. They already laid out the foundation. They're working on it now, and how many, you know, the hardware in terms of things that they work on, and then they will just figure out pretty much the standard things that if you're designing a 3D camera, or if you're designing a LiDAR, or if you're designing an ultrasonic sensor, if you're designing, for that matter, UI, if you're designing, for that matter, how to supply the power and stuff, you know, and everything just mostly standardized. You know that what it's going to need in order to work with the other ROS2 components or ROS1 components, you know, or even to leverage the whole software stack of it, kind of a deal. Be very interesting. I mean, I'm thinking that would be very interesting, and so for the actuation part too, you know, I'm getting more excited about the hardware side of things, and I think that they have picked up the project at the right time. I think because we need lots and lots of like right now I always think about it like the biggest problem is how to connect it with the hardware and how to run it to the hardware, how to control it, you know, and then we have several hundreds of motors, you know, you have several hundreds of the different hardwares, and it's just very like difficult to make one thing work, you know, end to end, and then just having, you know, have that confidence that, okay, you know what, it's just going to work. It doesn't matter in any situation. And as soon as you change the hardware, you know, the whole game changes. So I think that should not be the case, or at least to minimum, you know, it should actually, we should have only few ways to do it rather than right now, like there are thousands way of controlling your low-level hardware, you know, so that I'm looking forward to get some, you know, these like standards and protocols just come into the picture, and you can just simply go by that, and it just makes things easier to control.
Did you get a chance to watch any of the ROS conference videos?
Yes, I did. I started I watched about 3 or 4. I haven't completed yet, but I think they were very interesting. And thanks to Sohin and Jeremy, you know, we had some more glimpse. You know, I was like last time, you know, I was just literally walking through the conference. You know, so yeah, it was just very nice. Absolutely, yeah.
It was like show stuff. I was kind of showing off, but you know.
No, it's always fun. I wish, like, maybe, I don't know, next year or year after, wherever I get a chance, you know, we'll just go and attend the conference. That would be a good idea. But yeah, that's the one thing that I liked about the H-ROS, actually.
I joined and I was wondering, someone was talking. I think it was
There's some feedback on that, Sam. Can you hear that, Sam? That feedback?
A feedback?
Hello.
Okay, that's good.
Oh, okay, yeah. So I joined late, and I heard Jeff and Kyler talking about the new Swift map. The Duro with INS, and I wanted to ask Jeff if he's or his company is planning to buy it, or, you know.
Well, I assume since it's out, probably the next one we buy, we'll just go ahead and buy that one and pay the extra, because we're buying the the base Duro unit anyway, and probably for whatever extra money it is, we'll probably get that one to try it out and see what it does. And Sean made the comment they'll probably get one and try it. I don't know if he made that privately to me or on the list, but so they're going to try it out too, I think.
Have you been testing the multi versus the duo, or are they the exact same thing?
As far as I know, it's exactly the same thing. The one advantage to the Duro is that it comes with a cell modem built right into it, so you don't have to add anything externally if you want to get your correction data. And it could be that they've got it locked down to the point now you have to run it with their Skylark service or whatever they call it. And I don't know. I haven't tried it at all because of the way our network is set up. I don't know if we can turn that on and get the data back out to the computer. And so far, we haven't tried that. We've just basically ignored it so far.
Have you been happy with the multi?
It seems to be working adequately at this point. Yeah, we don't have one right here that we play with constantly, but you know, anytime anybody runs it, nobody's complaining about it so far. So it's finally gotten to the point where it works well enough, I think, that you just buy it and use it. Except for the fact when they came out with the new 2.0 software, they locked a bunch of stuff down, and you can't do as much with it anymore. And they made a comment right on their notes that said, if you want to do development, you should stick with version 1.5. So that's what I did. I compiled 1.5 and was putting my CAN stuff into that. And 2.0, apparently they've locked it down. So number one, originally they had you could just log into the thing with a root password, or just root with no password. And I think they finally realized that, you know, they need to lock it down a little more than that. So that's one of the reasons. So on the new stuff, you can't do secure shell into it anymore, and you can't do secure copy into it. And they were saying that something about you don't have access to the SDK anymore. I'm not sure what that means, but I just backed off to version 1.5 and decided to play with that. So that's kind of where I'm at right now.
How does the functionality affect from 1.5 to 2.0? I mean, it's a version 2, so I would assume that it would have more functionality, or it makes more use of the sensors on board, or is it almost the same?
I think they added. I think they added a little more functionality for the user, but mainly it was for their purpose to lock it down, so you can't do as much with it. You know, so it's when they just announced today they had the version 2.1, which they said has SBAS smoothing and something else, and I think it was just in preparation to lock it down so you can't do as much with it.
We are contemplating whether to go with the Pixie or stick with the MLIT as they roll out these new features with Skylark and other services. Well, Skylark is not available in the ANA region. I checked that, and even Kyler said that it's not available in that area, which was pretty surprising. But we're trying to find different options to the MLIT GPS that we're using currently. So I wanted to just see or know how things are working out on your side, and is it worth buying? Is it worth spending the $2,500 for the whole kit? You know, the evaluation kit.
Well, I think the evaluation kit is $2,000, and you get two complete receivers with that. And plus, they give you the radios to talk back and forth if you want to use one of those as a base station and the other as a rover, then you can do that. Or if you just buy the kit, you get two receivers and you can do two complete robots if you get your correction service, say, from the Department of Transportation, which we're still doing that. We haven't looked into the Skylark service or any other service, because as long as we can get it for free and it works, we're pretty happy with that.
I didn't think of using the Department of Transportation. It's funny because I just talked to them this morning. But thanks for that.
I think Kyler said that's what he's using there in Indiana, so I'm pretty sure it works there.
Yeah, of course. Yeah, I would bring it up to the stakeholders. Thanks.
Have you made any progress on your robot, Jeff?
Well, I worked on it all weekend, and I had decided that instead of building a metal frame for it right away, I was going to make a wooden frame so I could basically lay the thing out and see what was going to fit, see if things are going to hit other things and what I'm going to have to do to move it around. And sure enough, when I got it put together, it wasn't going to work the way I was hoping. And it also got me to the point where I didn't know how I was going to hook the front axle on, and I've been playing around with that. And when I started welding these things together, I was using, this is one of the bolts I'm using for my front axle, so that's how big it's got a 10-inch wheel that slides onto that. And then I had another bolt welded on like this. And I found it very quickly, my welding skills aren't really adequate at this point, so I made a mess of the whole thing. And the first side turned out okay, and the second side it was way off, mainly because I put my two bolts together, and I was supposed to hold the bracket on while I welded it. So I did my weld and looked down, I forgot to hold the bracket on there, so that wasn't welded on straight. But I thought, well, the bolts are bolted down at 90-degree angle, so I went ahead and welded everything together. And then I went to put my control arm on, and I forgot that the thing wasn't straight. So when I put that on now, the control arm, so my axle sticks out like this, and the control arm's at a weird angle. Instead of being flat like this, it's down like that, because I wasn't paying attention when I put it together. So I may redo the one side. And then also, I mentioned last time at one of the meetings that I bought, let's see, I gotta do screen sharing here. I got a blank screen. Oh, there. Okay, so I mentioned that I found this motor, and it's got a lead screw on it, and it's got that follower nut. And they give a little video down at the bottom so you can see what it looks like, and they show it to you, and they show you how fast it turns if you hook it up to 12 volts. And here's their little 3D view of it, so you can look around at the thing and view the whole thing. But I actually have a couple of these on hand, so I know what they look like. And then today I ordered their other one they have, which is this one. It's a Pitman motor. It's got a longer lead screw on it and a plastic follower nut. And here again, here's their 3D view. You can scroll around and look at it. And I'm going to try this, because when I had it all set up on the table, it looked like I can just take one finger and move the wheels back and forth. So I'm hoping it's not going to take a lot of force to do it. So if I can get this motor to do it, then I can just take a hacksaw and cut it off the length I want. So if I need a 4-inch travel or a 2-inch travel, I should be able to do that. So I've got that on order. Maybe by the end of the week that'll show up, so I can try that out. And then maybe this weekend I'll get back to working on the frame again, and maybe get it far enough along that I'll know if it's going to work or not.
That'll control your front steering.
Yes, it's basically to build a linear actuator instead of trying to buy one. Because when I started looking for linear actuators, the list went on and on. I couldn't find what I was looking for, and they seemed to be expensive enough that I didn't want to just get one of everything and try it out. So these motors are somewhat cheaper. I'm going to try them first and see how they work out. So I'll need one of these as a linear actuator to move the wheels back and forth, and then some kind of a position sensor, and I'll either use one of those Hall effect sensors that I know everybody else is using, the Delphi, and I found some at our local surplus store that they're off a 2012 Corvette for the headlight angle sensor or something. I don't know what they were, but they're basically the same thing, a little bit smaller than those Delphi ones that other people were using. So I might use that, or I might put a potentiometer on it, or I'll just have to see once I get it all put together, see what makes sense to do on that.
That's progress. That's pretty cool. I did pick up one of those. These are like that one that you are showing. It just got a little screwdriver with a bolt. That's slow. It will run off of 24 volts, but I haven't measured the speed of like how long it takes to get an inch or something.
Yeah, this last one I showed, I think they said it takes 4 inches to go from one end to the other, and they said it's like 8 inches to travel. So if I cut that in half, it'll take 2 seconds for the full travel. So hopefully it seems like so far everything I've looked at, this is the fastest one I can get. And I want it so it can move the wheels back and forth fairly quickly, and then I can slow it down in software if I decide that it's, if I don't like how fast it's moving. I can always, basically if I specify the position and let it follow that, I think that'll work out. But a lot of these, a lot of the actuators I'm looking at are way too slow, and you know, you would spend all your time waiting for the wheels to catch up. So I'm trying to find something fast enough to just take care of that up front.
Yeah. There's a big price difference between these screw drive ones and linear actuators. I don't know why, but. And then you got two electric motors. Those are on the back or the front with your encoder. So you're going to have steer angle, and then you're going to have an encoder for your wheels.
I have an encoder on the back motor, so I can control the speed of the motor and measure the position. Plus, I'm going to put an encoder on both back wheels. So I'm actually going to have 3 encoders. So the 2 on the wheels will let me do full differential drive odometry, so I can get distance and speed and heading off those 2. And then the one on the motor, the main motor, I can keep track of the speed and then also measure distance with that one. So I can switch from one or the other to experiment to see how it works out. If I can make it all work.
You can make it work. Yeah, it'll be interesting to see the differences, because you have one encoder on the motor, which should be the speed, but then the individual wheels as you're turning are going to be different than the center encoder. So that'll be interesting. Have a nice redundancy.
And actually, I think with that mechanical differential, I think it's basically, that takes the average of the two wheels. So at the encoders on the wheels themselves, you read both positions, and then in software, you take the average. That's just the way the odometry equation works. But then the differential is just a mechanical way of doing that. So you just turn the main motor, and as you do, it just averages out between the 2 wheels. So as you say, it's going to be interesting to compare the 2 and see how that comes out.
I was looking at this today, or yesterday. It's basically just odometry from encoders. And they're kind of a couple different formulas that they're testing. Are you going to use the Lino robot as your robot base software?
Probably not. I'll just take whatever. Just put the modules together and make it run. And I'm not sure if I actually use anybody's particular software. But again, when I get that far, I'll see what I come up with. And actually, the low-level microcontroller is going to be, it's going to all be written from scratch. So basically, you take in the command velocity and then convert it to. I have to convert it to forward speed for the back motor, and then convert it to steering angle for the steering motor. And then when I recover the odometry, I can send that back up to my ROS node. Probably as 2 separate odometry messages, two completely separate odometry messages.
I think Al was able to drive the simulator this week. I don't know how far he made it on the rest of the project.
Oh, I'm done.
I think Sohin, one time we were talking and laying out all the stuff that we needed to do, and Sohin was like, that's 3 to 5 years worth of work.
I was going to say, and then I woke up and realized I was dreaming. Also, Matt's correct. I mean, with his help, gave up on the Husky simulation, GPS waypoint navigation, moved over to what Matt had done, came up quickly. Next step is just simply to drive it with the gamepad, and then get the RPi and Verizon MiFi device and all of the off-board stuff working. So the motor, got the DC motor on order, got the steering shaft ready to be hacked off, and I've got a call out to a U-joint manufacturer to see if they have a 5/8 inch round to 3/4 inch 36 spline U-joint in their inventory. Their website seems to suggest it, but there was a bit of a conflict in some of their documentation. So hopefully, if that's the case, and they do have it, then, you know, Matt, we can somehow memorialize your makeshift steering joint device and replace it with something with a little bit more beefiness. So anyway, small steps, making progress.
Awesome. An update from last week's meeting with Earth Rover. We are still looking at localization. Right now, we're working on a survey to send out to people to try to get some feedback on how accurate they would like the GPS, what is kind of their goal, and then what's the price point that they're wanting to pay. So that's always a little bit of a tough game to try to find that, you know, versus the hobbyist that's willing to pay at $2,000 or like $200, or versus maybe at, you know, commercial interest at $2,000 or $6,000. How do we get some reasonable accuracy with the GPS down at a lower cost?
Has anyone seen that the Spark Fund released the GPS, and there are like some other, you know, hardware to support it to get the accuracy of about 2.5 centimeters, and that's what they put it in quotation mark. That's just the accuracy. The precision is about 0.1 or 0.5 millimeters. You know,
that's amazing.
That's amazing. I'm not sure that if somehow that can be utilized. They're also saying that that they can utilize the long range network, and they have some hardware for it too. They also lay out that how you use the long range network, like the Things network, I guess, which is very popular, comes with some limitations, but what's that signal? The correction signal is what, RCTM or something, and how to get those signals too. So I think the whole project can be done, I don't know, within $600, because I believe that you wanted to use the one base station, also the same hardware, and once mobile, also the kind of the same hardware, and see if you can get to the point where you get the accuracy of about 2.5 centimeters. I'm not sure. I mean, it just looks optimistic. I'm not sure how that falls between the SwiftNav and all those things that we talked about, which is like running to the about $2,000+ or something, versus, you know, this project maybe about $500, $600 maybe at this point, I'm thinking. But has any experience with that kind of an hardware? Did anyone build that, or anyone's planning to build, or to see if that has any potential? If one of us just build that and prototype it, I'm not sure. If I get more consensus about, like, if that it's something that we need to pursue, then what I'm thinking is I can go ahead and build that kind of as a prototype project, maybe in next 3 to 4 months, up to 6 months. So I'm not sure, but I just wanted to know that how people feeling about that the hardware. And if you guys are optimistic about it, that should something that can be deployed, or we can use that in any of our future projects. I'm not sure. Just let me know.
So I just posted a link to the eval kit for those chips. And you get 2 receivers and 2 radios for $400.
Okay.
It's on a board with connectors and basically ready to go.
I believe that's the same chip. Neo M8P2. Yep. Okay. Oh, this is cool then.
And the one from SparkFun is just a chip soldered down to a board, so it doesn't necessarily have, this probably has your power supply built into it. It just seems like this might be a money more well spent than going with the SparkFun one.
With the U-Blocks kit?
Yes, if that's the chip you want to go with. And if you notice at the bottom, you get 4 different variants. So the radio that sends data back and forth, you have to buy it for the country that you live in.
Right.
And I think 915 megahertz is what, yeah, it says USA and Canada is what we would use. So really this is the same thing as the kit from Swift, except this is a single frequency and Swift is dual frequency. So Swift is charging about twice as much for that capability. Now another point, the Swift comes with much better antennas than what this will have. And my little one is going to show you right over here. It comes with a little square patch antenna. It's about this big, whereas the Swift comes with the big. It comes with what they refer to as a survey grade antenna, and this patch antenna is about this big, and this gives you more gain and possibly just works better. I found that all the stuff I've tried works better with the fancier antenna. And Swift will sell you this and the cable for like $188, I think is what they want for it. But the little patch antenna is $20, so there's quite a difference in price. And the one that comes with the IMLID Reach is about a $100 antenna. It's somewhere in between in quality, and I don't know. I don't have one of those to play with, so I don't know how well that works. So again, there's lots of options you can try here on this stuff, and it's just kind of a long path to go down to figure out what to actually use.
Any word on when the new U-Blocks is coming online?
The only thing I found, I watched that seminar they had, and they said, watch for around the end of October for us to announce that it's going to be out. And they always say, contact your sales guy. And it looks like we've got one on the East Coast, one on the West Coast, and I didn't want to go down that path at this point. So when the first ones show up, people are going to announce, this is what it costs, and it either works or doesn't work. So I think I'm just going to kind of kick back and wait for that to happen. And their excuse was they're just ramping up production, that they think they have it working, they're going to ramp up the production, and then they're going to release all these at the same time. So we'll have to get reports back and see how that goes. And if it's not terribly overpriced, I'm thinking that might be a good way to go. But again, until we get reports back from people, we won't know for sure.
What accuracy are you trying to get with your robot, Jeff?
Well, speaking of the U-Block stuff, this is the this is the one I've got, but it's basically the same chip as the one that Sam was talking about, but it does not have the software built into it to do the calculations. So you have to plug this with a USB cable here into a laptop and run RTK Lib to do all the calculations. Or I've had it running on a Raspberry Pi before. So basically this chip, this module is $75 plus a computer to run it on, and this will give me the RTK. But again, it's single frequency only, so it doesn't lock on as fast as the dual frequency, and it may drop out easier than the dual frequency ones. And again, this one works much better on the Swift antenna than the little $20 antenna that it came with. So that again is that's my theory on that. That if you buy the decent antenna, if you want this thing to work, just get the best antenna you can, I guess is what what my theory is at this point. Now, I think I saw somewhere in China will sell you one of those survey grade antennas for like $88. At least it looks the same, whether or not it's as good a quality. I don't know. It's hard to know by, you know, seeing something on eBay saying, yeah, here, buy this from us. It's great, but you don't really know. And it would be hard to find anybody that would give you a decent evaluation because, you know, nobody else is probably buying those things. So it's hard to know. And you ask, what kind of accuracy do I want? Well, it just seems like you either run RTK or you don't. And if you're running RTK mode, you know, you're going to get 1 to 2 centimeters. And if you don't, the next one up is like 1 to 2 meters, I think, is basically what you end up with. So it's just really a matter of which way do you want to go on that. And it really comes down to the matter of what do you want to do with it. You know, if when I was out to Bob's place, we were talking about that, and he was saying, you know, he needs this really high precision. I said, well, if you're just trying to move your vehicle from here down your driveway and then drive through the gate to get into the pasture where you can do the mowing, you may not need something extremely accurate. You need to know basically you're going down the driveway. When you get to the gate, you could have something else, either a camera or some lights on the posts or some kind of tags that a camera would look at or something. So you may not need really high precision to do this. And he was talking about just mowing his pasture. I think at that point is what we're talking about. And if you're just mowing and you can do some overlap and it's not that big a deal. So. And then if you get really creative, you might be able to use a camera to tell where you've mowed and haven't mowed. So it all depends on your end application, how much accuracy you really need. And then if you don't care how much money you spend, then you just buy a fancy thing that's accurate to the wind within 1 centimeter all the time. But if you don't want to spend that kind of money, then you have to do the trade-offs and figure out, you know, what you really want out of the thing. And actually my single frequency one gives me great accuracy as long as it stays locked on, as long as I stay out in the open area, you know, like 99% of the time I get a decent fix and I know exactly where I'm at, but then just randomly it'll drop out for, you know, 30 seconds or something. And if you get close to some trees or you get close to a building, it might drop out. And again, that's where the better antenna gives you better results than the cheap antenna. And it's, I was thinking, Al, didn't you say you have some of those IMLID reach receivers? Was that Sohin that was, I thought several different people said they had those types of receivers.
I did. I had them, and I mean, they're in a box someplace, but I couldn't keep RTK fixed. It would go to I think it was the reflection, you know, from I don't know what, but it was unpredictable, and so I gave up on them.
And actually, those modules have the same chip that's on this one. That's the timing based. It's the M8T from uBlocks. So it's got that same module, but on the back of theirs, they've got a processor to do all the calculations all in one module. Whereas I have to plug mine into a laptop or a Raspberry Pi to do the calculations. And I found that. And if I run, you know, a cheap antenna on this, I do have problems with it. But if I put the better antenna on, it does seem to do a reasonable job. In fact, one day when I was driving back and forth to Jimmy John's, I tested this one and the Swift at the same day. This one was actually stayed locked on better than the Swift did. Now, I must admit there's a couple versions back on the Swift software, but I was surprised to see this was doing a good job with the Swift antenna on it. So. Yeah, it's
Lost Jeff.
Yeah, we're waiting on him to come back. I was just going to say my testing was with the cheap antennas, you know, the out of the box antennas.
To make it work. So you have to decide, you know, is that what you need or not? So. But as Matt points out, if this new uBlocks receiver comes out, we can test that. And that might just be the answer to everything. Or the fact that Swift is saying, well, we'll sell you just the processor and hook it up to what I think Broadcom makes a chipset. And that should be cheaper than some of the stuff I've been seeing. So there's a lot of stuff on the horizon, but it's always, you know, oh, do you want to wait a week or 2 weeks or 2 years to see if it shows up? And
Takes time.
so I guess that's all the thoughts I have. Yeah. I guess
Excellent.
another example is you're asking me how accurate does mine have to be? Well, we'll ask Matt. He's not got a lawnmower. How accurate does your lawnmower have to be? And are you willing to run over the neighbor's cat or the flower bed or things like that? So that's kind of where that comes in. You just have to decide, you know, if you're just out in the open mowing back and forth, it's not a big deal. But if you have to now mow up next to the house, you don't want to hit the house. And if there's a flower bed, you don't want to mow all the flowers off. So you have to decide either, do you need your RTK GPS to be accurate, or can you, say, use a camera or something instead? Or just have an arm that sticks out and rubs against the side of the house, so you know where a feeler to know where the house is, so you don't bang into it. So there's various ways to get around that.
Lawnmower with a couple curb finders. All right, looks like Al, did you have a comment, or we're running a little bit over here? You mute some.
I was just going to share with Jeff, the testing that I did on the inlet stuff was with the out-of-the-box antennas, so I never bought the connectors to hook them up to my antennas that look a whole lot like the Swift antenna you showed earlier, but who knows what's inside.
Yeah, it's very possible those are the same type of antenna. And as far as connectors, I bought a bunch of adapters so I can hook all my stuff up to different things to try them out. But that might be your answer right there. If you try the IMLID on the bigger antenna, that might give you good enough results so you'd be happy with it. But as long as it's going to be the L1 receiver, just that single frequency receiver, it's not going to work as well as the dual frequency receivers in the long run, but it might work well enough for most people.
Fascinating. Excellent. It's good discussion, interesting topics. Looking forward to see the new hardware coming out here in the next couple months. It's good seeing you guys. Hope you have a great week, and we will see you on the Slack channel.
Thanks, guys.
See you, man.
Thanks, Matt.
Good.